Okay. Hey guys. So thanks Greg for the introduction. So I see a lot of tired faces, and I'll try to keep this as short as possible because I know everyone wants to get home and get back to where they're from. So today I'm going to talk about Open vSwitch and pairing it with P4. So I'll give an overview of what exactly P4 is and what it can be used for. Then I'll talk about the benefits of pairing P4 with OVS. Then I'll give a high-level overview of packet processing in OVS, and hopefully you can see how P4 affects this packet processing. And then I'll finish up by giving a performance comparison between OVS and OVS plus P4. And hopefully we'll have time for any questions you guys may have at the end. So what is P4? P4 gets its name from a SIGCOMM paper titled Programming Protocol Independent Packet Processors, which is a bit of a tongue twister. And it's a high-level domain-specific language, where the domain here is network forwarding. So obviously you can use it to describe packet processing or packet forwarding applications. It's completely open source. It's licensed under the Apache 2.0 license. And one important thing to note is that P4 is completely protocol and target independent. So what this means is that rather than supporting a subset of protocols, P4 supports any protocol by requiring you to define the particular protocols you want to use in your application. So here at the left of this diagram we can see an example of some P4 syntax, and immediately you can see some of the advantages that you can get by using a domain-specific language. So here you're setting up a table, which is a forwarding table, that will forward packets based off the content of the IPv4 destination address field. And then on the right side of the diagram you can see some targets that P4 can be compiled for. So one very interesting one at the moment are smart NICs, and there's a number of POCs around this area that different companies, even some of the companies here, have. But what we're concerned with today is the general purpose CPU. And in this model, P4 will be compiled to C code, which will then be included with OVS and compiled into your resulting application. So, what are some of the benefits of pairing P4 with OVS? The first one is that one of the problems with standard OVS at the moment is when you're trying to add support for new protocols or new features. This isn't a very trivial task. It requires a good knowledge of the underlying code base and a lot of testing to make sure you're not breaking any existing features or protocols. So, with the table at the top right of this slide, you can see an example of how P4 would make the addition of features or protocols more straightforward. So for the first example here, the TCP flags, this is just adding support for matching on TCP flags like SYN, ACK, those kind of flags. And doing this in OVS required changing or adding 370 lines of code. And this was spread across about 10 different files. And doing a functionally equivalent change in P4 takes just 4 lines of code. And similarly with the connection label for connection tracking, you can see that there's a huge reduction in the amount of change you actually have to implement. So another benefit of using a P4-defined data path would be performance. And I think a good example that illustrates this is a layer 2 switch. So you can operate OVS as a layer 2 switch. And in doing so, you don't care about any of the higher level protocols. So you don't care about layer 3 or layer 4 protocols. You're only concerned with parsing and processing the layer 2 protocol. So if you use standard OVS for this use case, it would actually parse and process layer 3 and layer 4 protocols, which kind of leads to some unnecessary processing. So if you use P4 to do the same thing and describe your layer 2 switch application in P4, you can save on a lot of the processing overhead by only processing and parsing layer 2. Another benefit is the separation of concerns. So what I mean by this is that P4 kind of acts as a layer of abstraction for OVS. So if you look at the way things work now in standard OVS, if you want to implement a new protocol or a new feature, you work on the OVS C code. If you want to optimize or change how anything is implemented, you work on the OVS C code. But here you'd be separating this out into two different streams, where adding features and protocols is done at the P4 level. So you work on the P4 file. So any developers interested in that would work at that layer. And then people who are interested in the performance and implementation of P4 would work at the layer below, which is the OVS C code. And using this model, OVS becomes sort of a generic engine for processing and switching packets. And you describe how you want these packets to be processed and switched using P4. And the final benefit from pairing P4 with OVS is that it attempts to bring the feature sets of the two data paths on par, or it will make this easier. So to explain this a little bit, in OVS you have two data paths. One is the kernel space data path and one is the user space data path. Now the kernel space data path uses the Linux networking stack, and it uses an open vSwitch kernel module. And obviously the user space data path uses DPDK for all its fast packet I/O. And one of the problems here is that there's a feature disparity between both data paths. But using P4, it would make it easier to implement certain features and support for protocols by allowing you to describe what you want your data path to look like in an implementation agnostic manner. So it would make it easier to bring the feature sets of both data paths on par. So the idea behind this slide is just to give a high-level overview of how packet processing works in the OVS user space data path. And if you understand this, you can see how P4 will change this process. So if you receive a packet, we don't really care how the packet is received. The packet comes in, and the first stage that we're concerned with is the extract stage. So in this stage, particular fields from the packet are extracted. And the important thing to note here is that fields are extracted regardless of whether they're needed. And this is in the standard OVS case. So bringing back to my example earlier with an L2 switch, if you don't care about the higher level protocols, they're going to be extracted here, which is kind of a bit of unnecessary work. And after the extract stage comes the hash stage, and here particular fields from the packet are hashed, and this is done to speed up the last stage of the packet pipeline that we're interested in, which is the lookup. And this is performed so OVS decides what action to perform on a packet, whether that is dropping the packet or encapsulating it in a particular tunnel protocol or sending it out another port. So this is the way things work in standard OVS. And as I mentioned earlier, fields are extracted regardless of whether they are needed. And this implementation has to support a wide variety of protocols, regardless of whether they're actually being used. So if you add P4 into the mix, you can see that both the extract and the hash stages are dynamically generated, and they're generated based off your P4 file. And our contribution to this state was the hash. So we dynamically generate the hash function that OVS will use when it's paired with P4. So the important things to note here is, going back to, again to my example earlier, in the L2 switch case, you'll cut down on the amount of work that you're carrying out by only extracting layer 2 protocols and not extracting the higher layers when you don't need to. And you can think of OVS as being specifically tuned to your use case in this case, where you've defined your use case in P4. And finally, this is just a performance comparison between OVS and OVS plus P4. And this is a simple phi-to-phi test, so you're sending packets in one physical port and not a second physical port. It's one flow, 64 byte packets on one core. And it may not look too interesting if I mentioned all the great benefits of P4, and maybe you're wondering, well, why don't you see them here? But the idea behind this particular test was to see if a P4-enabled OVS would hold up and whether its performance will be similar to just the OVS case. Because in our P4 file, we've defined a similar data path so that the extract stages and the hash stages are similar. So here you can see that the performance does hold up, and that in both cases, the performance is quite similar. So really we're happy with the results here, and it kind of shows that you don't necessarily have to sacrifice performance when you're increasing the flexibility of your switch. using P4. So that's everything I wanted to talk about. So if anyone has any questions, I'd be happy to answer them now. Yeah.
So do you get an increased performance when you do your L2 example? Or you're bypassing? Do you get a better performance than this again?
Yeah, you do get better performance.
I sense there's an even better picture there that you're not showing us.
Yeah, but I mean, I thought it was an unfair comparison to show in the standard OBS case and the P4 case for the L2 example, just because there's so much extra processing happening in OBS in that case. So, you know, everything is still being extracted and everything is still being cached regardless. So we stuck to this kind of, you know,
I get the like-for-like comparison, but I'd love to see the result of the L2 test.
Yeah.
Where you can actually bypass the stuff you don't need.
Yeah, so I'd be interested, maybe, yeah, we could talk afterwards. Or,
great.
Yeah, thanks.
So is P4, with the P4, are you generating,
Oh,
are you generating a graph nodes of some sort? Because if you're saying if you're only doing L2, you only need to parse L2.
Yeah.
But if you have, are you doing then a lookup to match your flow to say that I only need to match L2 for that flow, or have you defined you have to support multiple packets in your vSwitch? Some of them MPLS, others cut the whole range. Does the P4 only define a single graph node that you'll work to the end of any particular node, or are you doing staged lookups? Because if you supported just L2 forwarding and L2 and L3, then you would still end up parsing L3 if they're on the same path.
Yeah, so the example I gave was pretty specific in that if you only define Ethernet, your layer 2 protocol in P4, that's all that will be extracted. But if you go and define IPv4 as well, that'll be extracted as well. So the advantage is it's quite specific, you know, in that use case. So for your example where you want to support MPLS or any higher layer protocols, you would have to define them in P4 so that they're extracted. And then you're not cutting down on the processing that the switch will do. But in the future, that will be, you know, kind of an area for some work in the actual compilation stage from P4 to C, where you'd be able to look ahead and see, oh, is Ethernet going to be used, or are the higher layer protocols going to be used for a particular, you know, graph or a particular path, and you might be able to hold off and not extract those fields. But at the moment, they would be extracted if they were defined.
Okay. Cian, thank you very much.
All right, thanks.
Thank you.